See multiple tornadoes, damaging winds up to 75 miles per hour or greater, large hail up to 2 inches in diameter or greater, and more fire. Good morning, I'm meteorologist Pew. Today is August 7, 2025. Today we have an enhanced risk, or a 3 out of 5, mainly in North Dakota, and a slight risk in the northern plains, and also a marginal risk, or a 1 out of 5, in the Great Lakes area. All those risks, including the tornado, the damaging winds, the hail, are all going to be present in the northern plains, but in the Midwest we may see an isolated wind or hail event. This morning we have 2 areas of convection, one in Iowa that's going to dissipate by this afternoon, but we also have elevated thunderstorms that are happening in North Dakota and Montana right now, but that should also dissipate as well. But behind that, we're going to see intensification of storms around 3 p.m. Central Time, and these are going to form into clusters and then eventually form into one big blob, or an MCS, or what we call a mesoscale convective system, that would travel from North Dakota to Minnesota. For the Great Lakes region, if something does happen, it would happen around 3 p.m. Central Time, and it would be very small and isolated cells. Briefly talking about the tropics, honestly, I don't even think there's going to be any tropical depression or storm risk in the eastern coastline, but for those in the southeast, I would still anticipate isolated cells that may produce a lot of rainfall. And then for the west, we have the exact same situation as we had yesterday, where we have a critical fire risk, or a 2 out of 3, from Nevada, Utah, Wyoming, and Colorado, and we also have an elevated risk in the Great Basin area and possibly isolated dry thunderstorms. Looking at 500 millibars or midway through the troposphere, we have a really amplified trough that's going to pursue itself eastward. And this is going to do 3 things for us. One is bringing in really good shear, which is going to tilt those updrafts and prolong those storms. 2, we're going to have the isobars spread out, with also winds increasing in these areas. So if you have winds aloft that are spreading out but also increasing in speed, you're going to have upper level divergence, which basically means upward motion. And third, we're going to have cooler air aloft that's going to be advecting into this area, and what that's going to do, it's going to help with the lapse rate. So any air parcels that are rising in this area, the more difference in temperature between the air parcel and the environmental temperature, the faster it's going to rise. And adjacent to all this, we still have that ridge in the southeast, and it's pulling in dry air a lot from the west into the Great Basin area. And we still have moisture present in the mid-levels in the Four Corners area, and what that means is, because of the topography of this area, the storms are going to be elevated, which means they're going to be formed higher than normal, and when precipitation falls, they're going to evaporate and probably not even reach the ground because the surface is so dry. So that's why lightning is going to pose a fire risk. In addition to this ridge, there's pretty good shear in the Great Basin area, and that's going to help with the rising sinking motion, or mixing of the boundary layers between the mid-levels and the surface, which is going to help with the wind speed and also make the air drier. Going back to the northern plains, we have a low pressure somewhere between Wyoming and South Dakota, and what that's going to do is going to bring in southeasterly winds and even easterly winds in North Dakota. And because this low pressure is going to deepen, it's going to increase the pressure gradient, which thus is going to increase those surface wind speeds. And these winds are going to transport warm moist air into this area, and dew points are going to be around the 70s. And with the convection that's happening in North Dakota right now, because we have all this warm air that's being advected into this area, we're basically going to have a cold front and a warm front just clashing into each other, which is going to produce even more surface lifts. And that's why we may